Did I say it correctly? Anastasia Kapuza?
Yeah, it's okay.
Okay, from the Institute of Education at the HLC University in Moscow, Russia. And she will talk about how concept maps with and without a list of concepts differ, the case of statistics.
Yeah, can you see my
Yes.
presentation?
Yes, it works well.
Yeah, great. Thank you very much, colleagues. I'm very glad to be here and present here my research. My name again is Anastasia Kapuza. I'm a research fellow in the Institute of Education in Higher School of Economics, Moscow. This study is a part of my PhD thesis about concept maps evaluation. And this part was published in the journal Education Sciences in this year. So I left here the reference to this work. What is the result of learning? Most researchers assume that it's a well-organized structure of concepts which are related to each other. Vygotsky and Osobel state that the good structure has a lot of interconnections. So the good structure is highly connected. Vygotsky also highlighted the difference between how we learn everyday concept and scientific concept. When we learn everyday concept, we firstly learn specific objects and then relate them to their abstract meaning. When we learn scientific knowledge, when we speak about some theories, we firstly learn abstract ideas and then refer them to observed objects in our everyday life. It is very hard to define what knowledge is exactly, but it is important that there are two types of knowledge in cognitive psychology. The first one is declarative knowledge, conceptual, abstract ideas, theories, theoretical knowledge, and procedural knowledge, more technical, task-oriented, specific, and this knowledge related to, for example, how to manipulate with specific objects. Why this division is important? It was shown that novices tend to use more procedural knowledge in their representations, while experts use more declarative knowledge in their representation of area of their expertise. So that good structure also should contain both types of knowledge or even contain more declarative knowledge. But how to measure how good structure is? Novak and his colleagues developed a method which called concept map. What is a concept map? It's a graphical representation of the relationship between different concepts. It allows us to see the structure which comes directly from the respondents. They should draw it by themselves. Concept maps consist of three main components. The first one is scoring method. There are two main approaches to scoring, to concept maps evaluation. The first one is holistic, and it's based on expert views and their judgments about how good structure is based on, for example, level of hierarchy or structural form. Quantitative approach use some objective, at least tend to use some objective indicators. For example, traditional indicators, which are based on counting various elements of concept maps and their simple calculations. For example, number of concepts, number of links, ratio of the ratio. But concept maps are naturally networks. So in the past decades, researchers use graph and network theories to evaluate concept maps. What are the advantages of this approach? Graph and network theories are focused on a more complex evaluation on a whole structure and how information is distributed within this whole structure. The second component of concept maps is format. Respondent could construct concept maps by hand, on computer, individually or in groups, for example, with teacher or with their colleagues. The third component is instruction or task. The concept map itself consists of topic or focus question, concepts, links and linking phrases, and the structure, the form of structure. And these components could be provided to students or not. Some types of instruction were already studied, for example, difference between forced and retrieved links, different labels of links, forms of structure, or formulation of focus question. But the using of a list was not studied yet. And moreover, some of previous research use holistic approach to evaluate concept maps. So there is a lack of objective information about different instruction types. Due to above, we stated the following research question. How do concept maps with and without a list of concepts differ in terms of connectivity and procedural knowledge using? Since these two characteristics is important to characterize knowledge structure as good or rich knowledge structure. To address this research question, we stated three hypotheses. The first one, that connectivity, which is measured by the values of different indicators, is the same for both instruction types. And the second and third related to procedural and declarative knowledge, how students represent their procedural and declarative knowledge regard to type of instruction. In this research, we use topic statistical data analysis. So I would like to clarify why statistic is a suitable case for such research. Firstly, statistics has strong terminological agreement. For example, all of us know what normal distribution is and why it is important for example, mean calculation. The second reason is the strict theoretical underpinning. It helps us to divide concepts to technical to reflect procedural knowledge and core to reflect declarative knowledge. And the third reason is the issues with teaching and learning statistics. There are a lot of literature about negative attitudes towards statistics and the negative consequences of focus on calculations and numbers in teaching statistics. We used data from 11 master students. They took a 6-month course about basic methods of data analysis or introductory statistics. 2 months after this course, they received written instruction to construct a concept map on the topic statistical data analysis without any additional instruction, only topic. 3 weeks after this first concept map construction, they received the same instruction, but they were also asked to use a list with 25 concepts. And they also could add no more than 2 concepts to their concept maps. How we constructed a list? We constructed a list based on, firstly, course curriculum and then previous research about statistics education and core concepts. We choose 9 concepts as a core. And then the first one, significance, we excluded from the list to see whether students would add it to their concept maps and represent it to their concept maps. In the list, 32% of concepts were technical to reflect procedural knowledge, and 68 were more abstract to reflect declarative knowledge. Core concepts are, of course, declarative, but we have more declarative knowledge in our list. To test the first hypothesis, we measured connectivity. We measured connectivity by 2 groups of indicators. The first one were traditional indicators, a number of concepts, number of propositions, their ratio again, number and percent of concepts with 1 and 3 or more degrees. We also used indicators from network analysis. It was diameter and the share of diameter to control the size of structure, because we believe that the size don't reflect the good structure. Then we constructed 2 common maps from individual maps for each type of instruction. We use number of edges between two concepts in each individual maps as a weight. And for second and third hypothesis, we counted percent of technical concepts and calculated the weighted closeness centrality for each concept. We also found communities with General-Newman algorithm. What our results showed us. Firstly, concept maps with a list were more connected. Decrease of concept proposition ratio and number of concepts with only 1 degree and percent of concepts with only 1 degree were significant. At the same time, diameter grows significantly, but number of concepts with 3 or more degrees and percent of such concepts was the same. So the rise in connectivity was due to middle level concepts with only 2 degrees. Here I would show you the common map, one common map for instruction without the list of concepts. And here I would like to highlight the concept significancy, which was excluded from the second list. Students used this concept, significancy, in their maps without a list. They related it to hypothesis, null hypothesis, statistical hypothesis, etc. The percentage of technical concepts was the same in both common maps. 2 out of our 11 concepts with highest closeness centrality were core concepts in case of instruction without a list. But in case of instruction with a list, 4 out of 4 concepts with highest closeness centrality were core concepts. It is important to highlight that 2 of 9 core concepts were not used in case of instruction without a list. It were sample and population. And the concept of statistical significance, which was excluded from a list, was not used in case of list using. Then we found 16 clusters in common map without a list. And the biggest 3 included 2 with abstract ideas and 1 with core concepts. But without a list, we did not find cluster with core concept firstly, and the biggest 2 clusters contain specific methods, relationships and hypothesis testing. And the core concepts were almost unrelated to each other, so they did not form a single cluster. To sum up, the first hypothesis was rejected because we found that there were significant differences between measures of connectivity in both instruction types. The second hypothesis was confirmed because the percentage of technical concepts was the same, and also we found very similar communities of specific methods in both types of instruction. The third hypothesis was also rejected because we found differences in patterns of grouping of concepts, and again, due to this story about significance. Here is a small example of one respondent's maps without a list and with a list. In terms of interconnections, the second map was more connected. What do results tell us? Firstly, different instructions lead to different results, especially in terms of content, of knowledge representation. Using a list stimulates students to evaluate carefully the role of each concept in structure, but it seems that they feel a list stress. They do not evaluate as carefully concepts' content and could miss something important. So concept maps without a list are better for summative assessment, for tests. And concept maps with a list better for formative assessment and to provide feedback to students. Thank you very much. I think I have time for questions and comments.
Thank you, Anastasia. And so, do we have questions from the participants?
Yeah, I have a question.
Yes.
Thank you very much, Anastasia. This is great work. So maybe you already mentioned in the presentation and I missed, but could you elaborate more again how the list was presented to the student? Was it presented at the beginning of the instruction, or was the list consistently available to them all the time?
They had written instructions. They had two papers. The first one with instruction, you should construct the concept maps on the topic statistical data analysis. Please reflect your own views. There is no right answer, etc. And the second one is instruction, what concept map is, etc. In the second measure, they had third paper with a list, so they could use it whatever they want.
Thank you very much.
Thank you.
You had a question?
Yes, Anastasia, I have one question. We have previously also discussed about the same question, but when you use the closeness centrality or weighted closeness centrality, you can find a certain set of the concepts, but in some cases, the very abstract concepts, they are not close to each other. Instead, the paths are very long ones. Have you taken a look on these properties, how the abstract concepts are connected through longer paths?
Thank you for your question. It's really big issue. But my point here is that I'm a constructivist. I teach in constructivism. So I think that there is no right representation of some area. And probably we don't, so I don't think that this core concept or abstract concepts should group to one group. But what we could see in this research that in case of instruction without a list, they group to one group. But in case of a list, they spread over the structure. And what I want to highlight this, that there is a difference. And I'm not sure that they should be close to each other.
Right. Thanks. Yeah.
Thank you, Wisma. I'm happy to see you.
Thank you very much. So if we don't have another question, we will go to the next speaker.